Gradient boosting. Gradient boosting is an ensemble technique that builds a series of decision trees where each tree corrects the errors of the previous ones. By combining the predictions of these trees, gradient boosting models create a more accurate final prediction. Popular implementations include XGBoost, LightGBM, and CatBoost, which are optimized for speed and accuracy. Let's go ahead, write the code for this implementation line by line with explaining each and every line of code implementing a gradient boosting classifier in Python. So let's get started. I'm going to open a new file and here start with importing the necessary libraries. From sklearn ensemble import gradient boosting classifier, which imports the gradient boosting classifier class from scikit-learn's ensemble module. Gradient boosting is an ensemble method that builds multiple weak learners, typically decision trees, sequentially, where each tree tries to correct the errors of the previous ones. Now from sklearn.model selection, we import train test split. This imports the train test split function, which splits the dataset into training and testing sets, allowing for model evaluation on unseen data. Next, from sklearn.metrics, import accuracy score and confusion metrics, which imports the accuracy score to calculate the accuracy of the model and confusion metrics to provide a breakdown of the model's predictions, displaying the counts of true positives, true negatives, false positives, and false negatives. Next, we'll import numpy as np. This imports the numpy library, which provides support for numerical computations and array manipulations in Python. Now let's get some sample data. Same as before, we're going to use the hours studied and grades versus pass fail. We created an x equal to np array, which defines the feature data x as numpy array. Each element contains two values. The first value represents hours studied by a student. The second value represents prior grades in percentage. The shape of x is 10, 2, meaning it has 10 example rows with two features as columns. Next, we're going to do y equal to np array. This defines the target data y as a numpy array containing binary outcomes. 0 represents fail and 1 represents pass. Now, this is a binary classification task ideal for gradient boosting model. Now, let's go and split the data into training and test sets. So, this can be done using the train test split function, which splits the data into training and testing sets. Xtrain and ytrain are used to train the model. Xtest and ytest are used to evaluate the model's performance. Also, we have the test size of 0.2, which specifies that 20% of the data should be used for testing, with the remaining 80% used for training. A random state is set to 42, sets a seed for reproducibility, ensuring that the same data split is generated each time the code is run. Now let's go ahead and initialize and train the model. So first, model equal to gradient boosting classifier with n estimators as 100, learning rate is 0.1, and random state equal to 42. This kind of initializes a gradient boosting classifier model with the parameters n equal estimators equal to 100, which specifies the number of boosting stages, which are trees, in the ensemble. A higher value generally improves accuracy but increases computation time. The learning rate of 0.1 controls the contribution of each tree to the final prediction. A smaller learning rate requires more trees, but it can lead to better generalization. And random state equal to 42 ensures reproducibility by setting a random seed. Next, let's go ahead and fit the model with xtrain and ytrain. This trains the gradient boosting model on the training data xtrain and ytrain. The model builds a series of weak learners, each one improving upon the errors of the previous one, creating a more accurate overall model. Now let's make predictions. It's a ypred equal to model predict xtest. What it does is it uses the trained gradient boosting model to make predictions on the test set, which is xtest. For each data point in xtest, the model predicts either 0, which is fail, or 1, which is pass, based on the learned patterns. Now let's go ahead and evaluate the model. To evaluate the model, we'll use accuracy score, which calculates the accuracy of the model by comparing the actual values, ytest, to the predicted values, ypred. Accuracy is the ratio of correctly predicted instances to the total instances in the set. Next, let's get the confusion matrix by calling confusion matrix function, which computes the confusion matrix for the model, providing a breakdown of true positives, true negatives, false positives, and false negatives. And then finally, let's go ahead and print the accuracy and the confusion matrix. So now this code demonstrates the use of a gradient boosting classifier to predict whether a student will pass or fail based on the hours studied and the grades. The model's performance is evaluated using accuracy and confusion metrics here, providing a comprehensive view of its classification results. Let's go ahead, save this file, and run it here. I'm going to clear the previous one and say Python gradient boosting. And we have the accuracy and the confusion matrix with the true positives, true negatives, false positives, and false negatives. It looks pretty much perfect. So if you were able to do this along with me, that's great. If you have any questions or problems or comments, let me know and I'll get back to you.